Okay, this is Blackboard Video Lecture 9A. The topic in this lecture is about linear models, the least squares regression line. So we've just talked about the relationship between two quantitative variables. Recently, you looked at the relationship between the number of loans and loan value. The relationship was linear when we looked at the scatter plot. The correlation coefficient of 0.984 indicated a very strong correlation. And so the next step is to estimate that relationship with a linear model based on the data that we've collected. And so we hope that this model will be useful for the U.S. government with planning and prediction for the loan or the loan value based on the number of loans. So the linear regression equation that we will create, it's not going to match reality exactly, but we hope that it's close enough that it will be useful. So we'll see this in just a minute. On the next slide, we'll look at the scatter plot that we've looked at previously with these two variables. This time, you'll see the linear equations included, and we'll eventually talk about how you come up with that particular line. And in this video, we want to talk about the concept of what a residual is. And so the main idea here is that the linear equation is built to minimize the residuals. So let me explain what a residual is. Okay, so here's this scatter plot that you've seen before with the number of loans as the explanatory variable and the loan value as the response variable. And now we have this line drawn in here, our linear regression line. And okay, where did that line come from is eventually what we want to find out. And so part of coming up with that line, we need to understand the concept of a residual. So let me draw in here one of these residuals. You'll see that the red points, that's our data. Those are those 62 values that we have in the data set. And those points don't perfectly line up on our regression line. And so, we said that we would hope that the model would be useful but wouldn't match exactly. So that difference between what's going on with the data and the actual regression line, those differences are errors in our model or residuals. So I'm going to pick a point. I'm going to pick this point right here. And for that particular school, that school has an observed loan value. And if we go across here, I'm going to sort of eyeball this. I'm going to say that the observed loan value for that school is around 27 million. And that's this point's observed from the data Y value. I should be writing bigger. Then if we look at the line, our regression line, for a school that issued that many loans, the model predicts that that school will have this loan value right here. So if we look and see, for that particular school, when a school issues this many loans, what's the model predict? The number, or the loan value will be, that value's right here. So we see that the model was off a little bit. The model predicted a loan value that was smaller than what actually occurred at this school. So if I come over here and sort of eyeball this, the predicted value based on that regression line for that point is somewhere close to 22 million. And that predicted value comes from our regression line. A regression equation. The difference between those two, that's the value of the residual. If we see how far off the observed value is from the predicted value, that's the residual. So this difference right here is the residual. And when we compute a residual, we always take the observed Y value first, and then subtract off the predicted Y value. we can see it for this particular point, the observed value was bigger than the predicted value, and so this point's going to have a positive residual. So if we look at the difference for this one, 27 million minus 22 million, the residual for this point was 5 million. Now every single point has a residual. I picked that one because it had a nice big gap there, so it was easier to sort of draw that. But you could do that for any point that's plotted up here. If we pick a point below the regression line, that point's going to have a particular observed y value. That point has another predicted y value based on the regression equation. And this time you see that the observed y is a value that's smaller than the predicted y. And so when you take a smaller number minus a larger number, for that particular point, we would end up with a negative residual. This pattern will always be true. Any of the points that fall above the regression line are going to have positive residuals. All the points that fall below the regression line will have negative residuals. If we happen to find a point that fell exactly on the line, and it's difficult to tell here, but if we had a point that fell exactly on the line, its observed y and its predicted y are exactly the same, that point would have a residual of 0. Okay, so that's the concept of what a residual is. Let's talk about why they're important and summarize a few things that we just went over. So the y value from each data point, the y value that's listed in your actual set of data, that's called the observed y value. The y value of your regression line that matches up vertically with each data point, that's called the predicted y value. And the difference between those two values is what we call the residual. And again, it's important with residuals that we always take the observed y value minus the predicted y value. Okay, the better that our linear model is, the better that our linear equation is, the smaller those residuals will be. If those points are really tight around that line, they're not going to deviate from our regression line very much, our regression equation, and so those residuals will be very small. So the better the linear model is, the smaller the residuals will be. Okay. How did we know that that was the regression line, that particular line that was drawn there? Perhaps we would have drawn a slightly different line. To pick the best line, we're going to use the principle of what's called least squares. We pick a line that minimizes the sum of those residuals, actually squared. I'll talk about why the squared part comes in a second. So we use a principle of what's called least squares. Okay, I'll talk about on the next slide why we're not just going to sum them up, but we're actually going to square the residuals. Okay, so we do have a fixable problem. I mentioned that the points above the regression line all have positive residuals, while the points below the regression line will have negative residuals. And so if we just add all those up, it turns out that they'll cancel each other out, since some are positive and some are negative, and the sum of the residuals will be 0. So it doesn't work to just sum them up. So rather than simply sum up the residuals, we're going to take each residual and we're going to square it first. And so here's our solution. We're going to square the residuals before we sum them up. And then we'll square those residuals, and then we'll find the line that minimizes the square of all those residuals. When you square a number, it's going to become positive. So squared numbers will always be non-negative. I guess you could get 0 if we had a point that fell exactly on the line. So we'll say non-negative. And so again, the whole concept of why that particular line, it's based on the line that it minimizes the sum of those squared residuals. All right, a couple more comments on residuals. I think I mentioned this before, but another word for residuals is error. It's the error in your model. And so sometimes we'll see an expression for residuals where we write E for error is the observed Y minus the predicted Y. And so for predicted Y, we often put a hat over top of that one. So recall this was the observed Y from your data. This was the predicted Y from your regression equation. Predicted. Now a note here that I'm sure that you'll go over in class. Software packages such as StatCrunch will automatically calculate that line of best fit for us, that least squares regression line using these principles. You do not have to manually compute every residual for every data point. StatCrunch will do that for us, but it's important that you understand that that's what they're doing and the concept of what a residual is. I believe that's it for this video.